says draw a ladder diagram, just like we did in lecture, for the energy of the electron in hydrogen for the n equals 1, n equals 2, n equals 3, and n equals infinity. My infinity symbol didn't really print there, but I'll make it again. N equals infinity energy levels in units of kilojoules per mole electrons. Label all the values of n with their energy values on the picture below. Okay, so for this particular question, we are going to draw what's called a ladder diagram. And a ladder diagram has rungs, and it goes like this. N equals 1 is at the lowest energy, and we don't always draw it, but we can think that the nucleus is down here. And it doesn't matter how you draw your rungs, as long as it goes 1, n equals 1, 2, 3, and higher. But I know that as we go from n equals 1 to n equals 2, there's a bigger jump. As we go from n equals 2 to n equals 3, it gets smaller, and then 4, 5, 6, 7, 8, 9, 10, and eventually we get to n equals infinity. And they get closer and closer together as you go. Okay, but now how do we actually calculate these? Well, I'm going to calculate, let's see. So n equals infinity equals 0 kilojoules per mole. Right. And then what I'm going to do is I'm going to calculate from n equals infinity to n equals 1. And I'm going to calculate, therefore, this energy. And I'm going to use this equation. E equals minus 2.18 times 10 to the minus 18 joules z squared, and I've run out of paper again. There we go. 1 over nf squared minus 1 over ni squared, and where ni is going to be infinity and n final is going to be 1. Okay, and let's see, zoom in a little bit. When I do this, I'm going to get z. Z is my number of protons. And my number of protons for hydrogen is 1. And remember, those are the numbers on the periodic table above the element. And then, let's see. So this is going to be 1. I have 1 in infinity. Now, I've chosen infinity as my initial point because 1 over infinity squared equals 0. And so that means that this part equals 0. And so number-wise, I don't have to worry about it. Then I come over here, so it amounts to 1 over 1 squared, which is just 1, times 1 squared, which is also just 1. So my number here is just E equals minus 2.18 times 10 to the minus 18 joules. And I'm not done yet, but any questions so far? Okay. Well, if you do, jump in anytime. So here we go. So the next thing is that this amount of energy is the energy for one electron moving from n equals infinity to n equals 1. And I know I've already said that and I've plugged that in, but because it is for one electron, I am now going to write minus 2.18 times 10 to the minus 18 joules per electron. And that set of units is not in the equation, but it's per one electron moving. And as we talked about again in lecture, as the electron moves, it gives off energy, and it gives off that energy in form of a wavelength of light. And that wavelength of light is called a photon. So this energy is the energy for one electron moving from n equals infinity to n equals 1. It is also the energy for a photon being emitted. And so I will now write E equals minus 2.18 times 10 to the minus 18 joules per photon. Okay. And so all three of these sets of units are fine for this equation. Any questions about that? Some good coffee. All right. So now that we have these sets of units, I'm going to change either of these into kilojoules per mole. And so I'll start with this over here. So minus 2.18 times 10 to the minus 18 joules per electron. And for joules to kilojoules, I know that 1,000 joules is 1 kilojoule. And I know that 6.022 times 10 to the 23rd electrons equals 1 mole of electrons. Here comes Avogadro's number back to haunt us on Halloween. How scary, I know. Okay, but here we are. And then now the last step is to do this math and then draw it on our picture here. So 2.18 minus exponent 18 minus divided by 1,000 times 6.022 exponent 23rd. And I get minus 131, well, I'm going to round this to minus 1,313. Okay, and so, right, minus 1,313 kilojoules per mole. Per mole of what? Per mole of electrons, because if 1 mole of electrons made this jump, that's how much energy would be given off. And if 1 mole of photons were given off, that's how much energy would be in that mole of photons. So per mole of electrons, per mole of photons, either of those sets of units are fine. Now to add this, we said that this was 0 kilojoules per mole. If the difference here is minus 1313, then the number that goes right here is minus 1313 kilojoules per mole. That's for n equals infinity to n equals 1. You also have to do for this one, you have to find the number that goes here using the exact same technique, and the number that goes here using the exact same technique. I would suggest that you always have n initial equals infinity and do the math that way. So there are 2 numbers missing from this. I will allow you to complete these two numbers and then upload it. Happy to answer questions, but I'm not going to do them for you just now. And then what else did I want to say about this? Oh, what can you expect on your exam? You can't expect this on part one, because this is just too big a question with too many steps. But you can expect me to say, calculate the energy in kilojoules per mole for one of these transitions. That seems like a question that could be on your exam. And I think you'll see it on the review. I think I put it there because it's fair game. But anyway, so you have 2 more lines to do. It's the same process, except for here you'll have 2 and then 3, and then you'll complete it. And hopefully that will give you enough practice to be ready for the exam for this portion. Any questions about this part, this question at all? Okay.